Hello everyone, myself Kalichalvi, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. So welcome to today's session on types of electrical drive in the classification, design and application. So electrical drives plays a major role in automation, industrial systems because they help in controlling motor motion accurately and efficiently. So in this session we will cover what are the electrical drives, how they are classified, different types of DC drives, AC drives and specialized drives, and how design thinking can be applied to choose best drive for a given application. Okay, so let's begin. What are electrical drives? So, an electrical drive is a system that controls the motion and operation of an electrical motor using the proper power conditioning and control strategies. So, in simple terms, motor gives motion but drives gives controlled motion. So, now the key components of any electrical drive system includes the power source, power modulator, electrical motor, load, control and sensing unit. So, power source where the energy comes from. So power modulator is nothing but power electronic converter that controls voltage, current or frequency. So electric motor converts the electrical energy into mechanical motion. So load is nothing but the mechanical system connected to the motor. Control and sensing unit is nothing but which ensures the accurate speed or torque control and provides the feedback. So overall, an electrical drive system is a complete combination of power electronics plus motor plus control plus load. So then we move on to the classification of electrical drive. So now let's classify electrical drives. We can classify drives in three major ways. First one is by supply type, and then by load type, and then by application. By supply type, AC drives and DC drives. This classification depends on whether the motor and converter operates with DC supply or AC supply. By load type, constant torque load, variable torque load. For example, conveyor requires almost constant torque. So fans and pumps which are requires the variable torque depending on the speed. Third one is by application. So electrical drives are also classified uh, based on where they are used. For example, for the industrial drives, conveyors, cranes, machine tools are the industrial drives. Automotive drives are electrical vehicle traction motors. Robotics, servo and stepper drives. Consumer applications, washing machine, mixer, HVAC systems. So drive type selection depends on supply, load characteristics and application needs. And then now we connect these topics with design thinking because drive selection is not one solution fits for all. So the first stage is empathize, which means understanding the real requirement. Here we analyze application domain. For example, is it a pump, a robot arm, uh, an EV, likewise. So operational conditions like continuous duty or intermediate duty, speed change, temperature or vibration. Load characteristics because load decides motor capacity and torque requirement. Then we assess performance needs such as required speed range, torque requirement, accuracy and positioning needs. So empathize helps us understanding what the user actually expects from the drive system. So next one is the define stage. The here we clearly define the problem statement and design objectives. So we define drive selection criteria, performance requirements and design constraints. So important key parameter is defining drive performance include speed, torque, accuracy, power rating. So for example, if the system needs high positioning accuracy, we cannot choose a basic induction motor drive. We may need servo drive. So the defined stage converts requirements into clear engineering parameters. And then the third stage, ideate, where we generate possible solution. So here we consider three categories: AC drives, DC drives, and then specialized drives. So DC drives are preferred um, where high starting torque and easy speed control are needed. So in this AC drive are very common in industries due to simple construction and low maintenance. For the specialized drives are used where precision control is required, like servo drive, stepper drive, VFD. These are all the specialized drives. So in this stage, we compare and shortlist the best drive option depending on application need. And then the next stage is a prototype. We build a workable drive system model. Common drive configurations are DC motor with chopper control and AC motor with VFD, step servo motor with encoder feedback. We already seen in your previous session. So now in control strategies, that is open loop and closed loops, and the final stages testing. So finally we come the testing is essential because a drive performance must be validated before implementation. So the testing methodologies include the load test, measuring efficiency and analyzing the dynamic response. So the performance validation is done for the speed, torque and efficiency. Okay, so the test stage ensures the drive is safe, efficient, stable and reliable. Okay, so and then so recap or summary. Here we take the key points. In this session, we learned electrical drive fundamentals, classifications by supply, load, and applications. So types of DC drive, AC drive, and then specialist drives, and how to design thinking applied in all the five stages: empathize, define, ideate, prototype, and test. So the key points are electrical drives are essential in modern automation, and choosing the correct drive type ensures the optimal performance, efficiency and reliability for different applications. Okay, so these are the key takeaway from this session. Okay, thank you.